Hello, hello. Today I have Negative Space by Viking Prime. And it's got a really long rule set. And I tried to condense it as much as I could for the box, but I will read the whole thing for you now. So the full title is Negative Space, or the Sixth Best Kept Secret. And that is by Viking Prime. So, rules are as follows. Normal Sudoku rules apply. That means the digits 1 to 9 will be in every row, every column, and every marked 3x3 box. The value of cells along an arrow, so this is a visible arrow, or this one say. The value of cells on an arrow must sum to the value in its originating circle. So as an example, if this were, say, a 6, this could be a 5 and a 1. That would sum to 6. Cells along a German whisper line must differ in value by at least 5. So the value here differs by this value by at least 5. These differ by 5. These differ by 5 at least, etc. And if you've done a lot of German whisper puzzles, you may be wondering how that could possibly work here. And that's where the next rule comes into place. It says place negator cells into the grid. So there's exactly one negator cell in each row, column, and box. Each negator cell must contain a different digit and has the negative value of the contained digit. For example, a digit 5 within a negator cell would count as negative 5. So it's kind of like doublers. It's these modifier cells that you have to have one in each row, column, and box, and you have a different digit in each instance. These cages, and we can't see any of these fog. I guess I'll read the fog rule in a second. The grid is partially covered in fog. Placing correct digits will clear the fog from the surrounding area. So in these 9 fog digits, which presumably hide the value of these cages, although in previous puzzles like this, Viking Prime puzzles, they're like almost all emoji, kind of to troll you, because by the time you clear it, you figured out once what it should be anyway. But anyway, what are these cages? Because these cages are not normal killer cages. Well, they might be, but they also might be 𝐿-𝐶 cages. So in a killer cage, cells must sum to the number in the top left corner if given. And if it's a 𝐿-𝐶 cages, so this is 𝐿-𝐶 cages that read as a 𝐿-𝐶, indicating which values are in the cage. For example, if the cage is clued as 21 or 2-1, there must be exactly 2 valid ones in the cage, along with any combination of other values. And you may be wondering why a 𝐿-𝐶 cage would ever matter in a 3x3 box, because there's exactly one of each digit. What does it say, digit or value for the 𝐿-𝐶? Which values? Interesting. Because that's going to interact with the negator potentially. So maybe there's a negator, like if it says 0, 5 or something, then I would know that the 5 is doubled, I think. Anyway, or the 5 is negated rather, because there are no value 5s, then that would be a negative 5, which is different. But when we get to the next rule, I think the 𝐿-𝐶 possibility will be more intriguing, which is that the dashed red mad fold-in lines, that's these 2 lines, there's one here, right, and there's one here, A, B, fold over so that A meets B. The dashed red mad fold-in lines are folded onto each other so that column 1, 2, and 8, 9, so these 4 columns. Sorry, I'm so slow making this. These 4 columns form a 4x9 grid. Arrows and cages must also be valid in the folded grid. So this will be a cage that will either be a killer cage or a 𝐿-𝐶, depending on whatever, and it will satisfy whatever clue is in this fogged corner. And the next rule is important here. It says the cage may have a different identity depending on whether the grid is folded. So this could be like let's say there was a 1 negated in this cell. Then as a killer clue, this cage might give me the clue 43, because that's what the sum of 2 to 9 are minus 1. So this might say 43. Well, let's do a different example. So I think you can get to 27, right? So 1 to 8 is 36. Yeah, minus 9 would be 27. So this could say if there's a minus 9 in here, This might say 27, and then I have a negative 9 somewhere in the box. But as a folded clue, right, that 27 could mean 2 sevens, right? There's a 7 in here and a 7 in here potentially, meaning there would be no 7s in those. I think in theory, these could also sum to 27. I have to be careful. It's probably, is it possible? I don't know. But strikes me as plausibly possible that these could also sum to 27. But so it's ambiguous. Just because I know if it's a killer or look and say in this 3x3 box doesn't mean I know what it is in this 3x4 box. Right. An arrow clue, same thing. So this arrow, if we fold A to B, this circle goes to here and then to here and up and around and then to here and back down, which is interesting because the arrow contains itself. So then these negator cells are going to have to do something. Digits at the bottom of the grid have been provided for tracking purposes. So these are just, I'm going to use these probably to track the negators. Anyway, so that's it. Those are the rules. And let's try it. So let's just reset the time. Where do we start? I'm tempted to start at these circles and see if I can rule out these circles as being negators. Right. I'm also noticing that, like with this arrow, this cell and this cell actually, I think those are only two. I don't know whether the arrow just continues through or if there's something like this cell where there's a circle here where this arrow could end here and then I have a new arrow going like this. Same thing here. This could just be an arrow like that. And then I have a new arrow doing this. I think either are possible in both cases. Anyway, this one strikes me as it can't be a negator. So this value has to be this value. Now the problem with this cell being a negator, or this cell actually, because these have to have the same value, is if let's say this was the example -5, then this also has to be -5, which means this has to be a negator as well, which is fine, except they would both have to contain 5. And the negator, that's a hard word for me to say right now. The negators have to have different digits in them. So these are actually both not negator cells. So I'm going to label blue, and I'll put reds in when I find the negators. And these are the same digit, which I'm tempted to mark A or something, but I will not, because I don't know how useful that's going to be here. Here, I'm going to draw this in. I'll put a circle here. I know there's an arrow circle here because I can see everywhere around this fog, so there must be an arrow, a circle in here. And I'm trying to think how this works. Sorry, yeah, and these can't be negators, which is originally what I was doing here. These can't be, and this can't be a negator for the same reason, and this can't be a negator for the same reason, which is, suppose this were a negator. Then these would have to sum to a negative value. But neither of them are negators because this one is, and they're in the same box. So these are both positive. They can't sum to a negative number. So this one, this one, this one, not necessarily this one. Probably this one, but let me be more careful. These ones cannot be negators either. Now this one, is there any way this is possibly a negator? Because if this is a negator, none of these are, which means this also has to be a negator. But that means this is not a new arrow. So if this is a negator, this is not. So this can't be a new circle. So if this is a negator, it has to take all 6 of these cells. And this is the only one that could possibly be a negator. So let's say this is -1, say, and this is -9. That would mean these sum to 8, which it can't do, because this is at least 6, because it's 3 in a row. This is at least 3, because it's 2 in a row. 1 and 2 is 3. 1, 2, 3 is 6. So these sum to at least 9, which means that if this is negative and this is negative, their difference is at least 9. And I can't do that with digits 1 to 9. So it just doesn't work. So this is definitely positive as well. This could definitely be a negator, right? That would work fine here. But let's look at these for a second, because I'm intrigued by how these arrows work on this German whisper line. Because if there were no negator cells, right? If there were no negator cells, what would have to do is on a German whisper line, you have to alternate between high and low, because between the digits 1 to 9, to have a difference of 5, you have to have a number that's 6 or more and a number that's 4 or less paired next to each other, right? I can't put a 5 anywhere on a German whisper line absent negators, because if I put a 5 here, none of the other digits are at least 5 away. So and if I have, say, a 6, then I have to go down to 1. 7 goes down to 1 or 2, right? 9 has to go down to at least 4. And if I'm at 4, I have to go up to 9, right? 3 can be 8 or 9. 2 can be 7, 8 or 9. So you have this alternating high-low property. Now, can this work with these arrows? I think I'm going to end up at least saying that these are not negators, right? So how does, suppose there were no negators on this line. How would this work? Well, these would have to be high, because if these can't be low, because if this is low, this is high, and we're already too big. We're assuming no negators anywhere on this. So if there are no negators, it's high, low, high, low, high, low, high. But, and so yeah, I think I see the problem, but it's kind of hard to explain. So suppose that, so somewhere on this, I guess there doesn't have to be a 9 on here. Well, yeah, there has to be 9, because these digits would then be 6, 7, 8, 9 in some order, right? And this is less than this, and this is less than this. And one of these two digits is a 9, because it's all symmetric. Let's just look at what happens if, say, this is a 9. I'm going to try to be careful not to put actual digits in, because that might accidentally clear this fog. Let's say this is the 9. Now, where does the 8 go, right? Now, it definitely can't go here, because this would then be less than 8. Won't work. Again, we're assuming no negators on this line. So this can't be 8. The problem with this being 8 is this becomes 8 and this becomes 1. But then I have 6, 7 here, which also needs a 1 here. So that doesn't work. So this can't be 8. So this becomes essentially an 8, 9 pair, one way or the other. And I have 6 and 7 left. And I can't do 7 here and 6 here, because that would mean 2's in both spots. So I need a 6 here. Well, I mean, more simply, I can't put a 6 in either of these spots. Oh, no, this is so much simpler. Sorry, that's too complicated. Look, the reason that I need a negator on here is because if I don't, these are all high, because the arrows mean these are all high, not all low. But actually, they couldn't be all low either. Yeah, no, they could be if you didn't have the arrows. So these have to be the highs. One of these has to be the 6, because I can't put the 6 in a circle. And the 6 would need a 1 and a 2 next to it. So those can't be negators. Can I do it with this as a negator? Now I can't use that 6 rule, right? So suppose this is the negator. Then I have, again, I still have, since there's no negator on the arrows, these all have to be highs still. Yeah, because these both have to be high. These aren't negators. So I have high, low, high essentially both times. And so one of these is a 6. And the 6 has, yeah. So if this is not a negator, one of these is a 6, which goes with a 1, because that's the only thing it can go with. So I have 6, 1, 7 in one of these arrows. But then the other problem is then the other one has to be 8, 1, 9, and I have 2 1s in the same box, actually the same row. So this can't be a negator either. Which means what? One of these arrows is real. One of these is a real arrow with non-negated cells. And that arrow is high, low, high. And since this is not a negator, that's low. So this has to be low. And it can't go next to, whichever is the real arrow can't have a 9 at the bottom. So it can't be a 4. I think I could do 3, 8, 1, 9, something negated, low, high. That would probably work. So I can't get rid of 3 as a possibility. can I figure out what, like, is there a problem with these being a negator cell? Right, so let's say this is the negator. Then I actually end up with high, low, high, low, high. This is a negator, so this has to be, this could then be low, actually. Huh, yeah, maybe there's not. Oh, it's probably this one. Hold on, let's look at this one. Yeah, this is more interesting because even though I can't see this fog, well, I wonder if this is allowed to not connect. I don't know if there's a rule about that. Yes, actually, I don't know if this is a ring because this might not go through in some sense. Like I can't really draw it, but this arrow, this side of the line could come here, and this side could come here, and they may not actually connect. So I have to be a little careful about how I think about this. So I'm just going to assume they don't connect for now. And what does that tell me? Well, this is surely high, right? I mean, so first of all, I think there has to be a negator on this line. Yeah, there has to be a negator on the German whisper. Otherwise, I mean, starting from one end, it's alternating high and low. But that means that these four are all the same type. And that, which is impossible, right? Because if this is low, it could be 4, 1, 2, 3, but 1, 2, 3 sums to 6, which is more than 4. And if it's 9, 6, 7, 8 is 21. So that doesn't work. So there has to be a negator on the line. So that's not a negator. Oh, so actually one of these is now a negator. That's kind of cool. Well, let's keep looking here. I think I'm going to end up that I need a negator on one of those two spots. But let me just, like, what happens if this is a negator? If this is a negator, I still get the same problem where these are all the same type, which doesn't work. So this can't be the negator. But like, could this be the negator? Because now I get these are the same type and these are the same type, but they could be different types. Oh no, because yeah. So it doesn't, and it actually doesn't matter. I don't know why. It doesn't actually matter if this closes or not, because these have to be different type, high, low, alternating if they're, if there's not a negator. These also have to be different types. I mean, this is 5 different from this because this line goes in regardless. It doesn't matter if they're connected. This line is 5 different from this. It doesn't matter if they're connected, right? The fact that it's connected makes no difference at all. So yeah. So I can be a little, so it actually doesn't matter where I put the negator here. If I put a negator here, this has to alternate. So this is the same type as this, as this, as this. It doesn't work. So none of these can be negators. One of these is, so these are not. Oh, and I mentioned this when talking about the rules. I have a negator here now because I can't have no negator on this triangle, because it have to go high, low, low. So one cell has to be both high and low at the same time. Doesn't work. So that has to be a negator cell, which means these are not. Okay, and now besides the negator cell, the other ones have to be the same type. But I don't know if I know it's high or low, right? Because I think I do 4, 2, 3, -1. That works. But I could also do like 9, 6, 7. Let's start -4. I mean, there's probably more. With lows, I think I'm forced to 9, 4, 2, 3, -1. I can't think of another way to do that. Like right, if the non-negator cells here are low, I want this to be as high as possible. the negator to be as low as possible. Right, because if I have negative, oh no, I could do like 4, -5, like 3, 6. Yeah, there's a lot of things that could work. Oh, but they have to be the same type. They have to be the same type. Well, anyway, it could be high or low. So I don't know. I don't know how to do this yet. Right? Well, hold on. This is still a 5. I think I'm going to get a digit here, right? This is still a 5. Because if I put a 5 anywhere on this, it would need 2 negator cells on either side of it. So yeah, so this is a 5. That's going to clear the fog. That's pink, not that. 5 clears the fog. 33. So 33 means we're 12 off, which means I have a 6 in here that's negated. So I think I could do like 1, 3, 4 or something. Hold on. Now where's 4? Where is 4 in here? 4 has to go in a corner because 4 would normally have to pair with 9, but it could also pair with the -6. So one of these is a 4. So if this is 4, that's 6 and that's 9. If that's 4, that's 6, that's 9. If that's 4, right? Sorry, if that's 4, that's 6, that's 9. So one of these is a 9, which means we're in high world. So so actually, so these are these are all high, 6, 7, 8, 9, and these are all low, 1, 2, 3, 4. Now I probably can figure out this has to be 9, I think, right? So 9 minus 6 is 3, plus 15 is 8. Wait, hold on. 9 is 15 minus 6, yeah. And if I try to do like say 16 minus 6 is 10, which doesn't work, right? 17 minus 6 is 11 doesn't work. Yeah, so this is a 9, which does give me that. So hold on, I'm going to come back to that. This is not a 9. These are not 9. So this is 6, 7, 8. The 6, I'm going to keep that 6 marked there. The 6 is what's negated. So actually, I'll mark this here too, as the 6 is negated here somehow. This is the same as this, so that's 7 or 8. That's probably all I can. So now, but now I've revealed this, right? So, well, I guess I should mention that this could be a look and say cage, but I can't put 3 3s. But I actually just completely forgotten that it could have been look and say cage. But it turns out it doesn't matter because I can't do 33. I can't do 3 3s in here. By Sudoku rules, I can't do 3 9. So this is 39, which means I have a -3 somewhere. So that's not 3. So somewhere in here, I've got a 3. That's negative. Oh, and I have a 5. Look at this. I've got a 5 on this somewhere. So I can't put a 5 here because if I put a 5 in the middle, one of these would not be negated and therefore would break the German whisper. So my 5 is in one of these corner cells. Oh, no. It's at one of the, it's in an arrow. It's in an arrowhead. And the 5 cannot possibly not have the negator, because if it doesn't have the negator, I'd have 2 lows next to each other. And the 5 has to be next to the negator. So one of these 2 cells is the negator. It's the negated 3. Because the 5 on the German whisper has to go next to the negator. And so whichever one that is going to have an 8 next to it, because 8 minus 3 is going to give me my 5. The other one that's not the 3, hold on, 5, 3, 8, 1, 2. So in the other cell will be 6 or then okay. One of these, let's say it's this one, is 5, -3, 8. Now what's in the other cell? Then the other cell is not negated. So that has to be a real arrow. And we don't have 8. So we have to have 9 as the, so it has 2 highs because it's coming off of this low. So if this is the arrow with the negator, 5, -3, 8, low, this is high, low, high. The highs left are 6, 7, and 9. Oh, could I do 617 actually? No, I can't do 617 because then this is 2. And then I have 6, 2 next to each other. So I have 6 or 7 with 9. So this is actually a 5-9 pair. I could use 7, 2, 9 with a 1. And I can't do 6 because 6 would need 3, but my 3 is in the negator cell. So actually this is an 8-7 pair. This is a 2-3 pair, meaning this is a 1, right? Because the 7 is going to go with the 9 and a 2. Again, I don't know which side is which, but that is the way this works. And this is a 4-6 pair. I get a 7-8 pair like this. So this is my 6. Is that right? Yeah, that's my 6, which is negated. So this is not the negator, which means that's the 2. This is the negated 3. And yeah, we get our first troll number. Yeah, I don't think I know more than that. Oh, but I know this works, right? This is 9, 7, yeah, 8. Oops. 8, 7. The 4 went with the 6 and the 9. This is a 1-2 pair with it from the 7, so this is my 3. 3 took 8 and 5. This is a 2, 3, 7. And the 3 is not negated. Hold on, we'll come back in a second. So this is all done. This, I can't do anything with that. These digits are 4, 6, 9. These digits are 1, 5. Okay. Okay. Now let's think about this line. Because it has a negator that's either 2 or 7. And where can that go? How does this work? Can I put a 3 in the middle? No. Okay. So here's the issue. Either 7 or 2 is not negated. One of them is negated and one isn't. And the 3, which is not negated for sure on this line, because it's already been used here, can't go next to either a not negated 2 or a not negated 7. So I can't put 3 in the middle, right? I can't put 3 in the middle because then it would go next to a negated 2, say, and then a not negated 7, and that doesn't work. So, and wherever the 3 is, has to go next to the negated cell, which will go in the middle. Yeah, okay. So my 3 is on the outside. It looks at the negated cell in the middle, whatever that is, 2 or 7, which is good for this arrow. It's bad in the sense that now I have a lot more freedom. But now I'm wondering if I'm going to get a 1-5 pair, like if this is a circle arrow or something. Anyway, I'm not sure. Same thing here. Oh, now that there's no negator here, this seems awfully hard to be a full arrow. Because I could have, at most, yeah, it doesn't work. So this is going to be another arrow. So here's why. Let's say there were no circle. We didn't have a cell like this where you have a new circle and the arrow stops here. So you don't have that. So this is just one long arrow. The problem with that is that there's just too many digits. So how could that possibly work here? Let's say I have somewhere here a negated 9, the biggest negative I could possibly have, and the smallest positives, 1, 2, 3, 4. That still gives me positive 1 on net from box 3. And over here, I've got at least 10. 4 and 6 is 10. So I've got at least 11 here, which is definitely more than 9. So that doesn't work. So I definitely need to have a stop. Like this is a new arrow. And therefore, this can't be negative, because if it were negative, these would all be positive, and it's just the sum doesn't work. So now this can't be 4. This can't be 9. Right? Because this is the sum of these. So what could this possibly be? If this is 6, we get 4, 2. This is 9, we either get 6, 3, or 4, 5. So actually, this is a fairly small number, looking at this arrow. So my negator, the negator is not in here. This is already 10 plus 4 is 14. It doesn't work. So my negator is not here. It's on this arrow somewhere. And it's probably got to be pretty big. Just rule out these while I'm looking down there. Like let's say I have 5, -9, 1, 2, 3. That's -6. Oh no. Okay. So my negator I think has to be 7 plus, but that's not that much of a, and only because 6 is taken and 5 works, but if I have a 5 in here, I get 2 5s in the equation. So, but I wasn't being careful about that because I'm not going to use that. I mean, it doesn't strike me as useful yet that the negator in here is 7 plus. Hold on, maybe this can't be 9. Maybe that's the way to think about it. If this is 9, yeah, the smallest I could make this is -3, of -9 with 1, 2, 3. So -3 and 9 is 6, which is too big for this. So this can't be 9. I do get a 9 here. Which gives me my negator cell. Hold on. So, but I think I can eliminate one possibility because this is not 6, 4, 2. Right? If this were 2, this would be 7, which it can't be. So that's not 2. My negator in here, because I can't have 3 1s from a look and say. So this is a real killer cage. So my negative value is 7. Which does tell me that this is the 2. Yeah, I'm going to get trolled here. I have and these are not negative. So this is not the 7. My 7 is one of these. So how does the math on this work now with a -7? Can I do 3? 3, -7. Yeah, 1, 2, 3. Oh, hold on, no. If this is a 3, 7, 1, 2, 4 is the lowest I can make it. -7, 1, 2, 4, because the 3 is taken. So if this is a 3, this has to be at least 0, and this is at least 4, so it's too big. So this is a 5, meaning that's 4. I'm going to get rid of that. That's mark that I had before. I probably can get rid of, hold on. If, a 7, 1, 2, 3, hold on. 7 and 1, 2, 3, -7, 1, 2, 3 is -1, and 6 works. And if I make this 4, I have room to just play here, actually. So I've got some to play. I have an X-wing on 7s of sorts, so I get a 7 in here. Oh, sorry, but this 4 so tells me that's a 6. So hold on. Is that the good way? Yeah, that's the way that is maximal. So these are 1, 2, 3, and 7. Because I have to make this as small as possible, because I have to make it -1. This 6 is already more than 5. This has to be -1. The only way to do that is to maximize. I already have a negator of 7, which means I need 6 in the other 3 cells. That'll be 1, 2, 3. I keep doing this, but it could be 7, 1, 2, 3, 7, 1, 2, 3. That's not a 2. This 5 looks over here. But that's the not helpful way, because it was probably going to be a 1 anyway by this arrow. Do I have to have this? Do I have to have a negator here? Let's say this is a 1 even. 1, 1, and -2 is back to 0. Yeah, if this is 8, even if I make this 1, 2 again, if there's not a negator, that's way too big. So I have to have the negator here. So these aren't negators, meaning my negator's here, meaning those aren't negators, therefore they're not 7. So the way I was doing it is correct by chance. This is a 1, 2, 3 pair. So these are 4, 6, 8, 9. There's no 9 here, which means I don't have a 9 here. Sorry, I have a 9 here, but I don't have a 9 here. And 2 is now taken. So this is only 1, 4, or 5, because 8 is gone as well. That doesn't strike me as that useful, actually. But 7 looks over here. 4 looks here. I've got a 2 over here for sure. Probably not in this, because this is a normal arrow now. Let's see, this probably isn't 7, 2, 9, but it could be. I wonder if I need to have my 9 here. I was thinking, where can the 9 negator go? But it could go down here. But I mean, 9 strikes me as very useful here. What is this negator? 1, 5, or 8? Okay, no. A lot of choices still. How about this? This is 6, 8, or 9. 6 would have to be 2, 4, but that's okay. I mean, unless 4 doesn't work on this arrow, but I don't know that I want to do that yet. What could this valve be? 1, 3, 4, 6, 7, and 8. There's no way it's 8, right? I have a negator here, though. Like, I could have a -9 here. That would make this very difficult to pin down. Well, does this have to be a 2 no matter how? So if this is a 6, it has to be 2, 4, because this cell is missing 1, 3, 4, and 5. So it's got to, if this is 6, we get 2, 4. If it's 8, we're missing 1, 3, 4, 5, 7. So we have to have a 2, 6 pair. And because of the 2 down here, it's got to be 2, 6. If it's 9, though, I might have more wiggle room. Yeah, I could do 1, 8, 2, 7, 3, 6. Yeah, I got a lot of choices. So where is the next place to look? It feels like it has to be this arrow. Oh, sorry, I have this. This 43 means that's a 1. Oh, which means I need a 4, 9 here, and that 1 looks at this. I just assumed they would all be emojis. I think I stopped looking for them. Yeah, so that gives me this. Right, so from -1, I have to go up to at least 4, but I need a low in this pair. So I need a 4 exactly, and the 4 can only pair with 9. So I get a 4, 9 pair here. Do a little bit of marks. So these is probably somewhat limited. 5, 6, 7. That's not 5, that's not 7. Almost useful. Yeah, I don't think that's helpful. Okay. How about this cell? 2, 3, or 8? No, it's not that useful either. Okay. Yeah, let's go back to this arrow. How does this arrow work? This probably has to be, like, there's no way this is a 7, right? If this is a 7, we've got 8, 16, 14. But I could have -9, 1. We're already done the 6. It's okay. I can do 2, 8 here. Wow, it can really be a 7. So there must be so much freedom on this. Oh, I wonder if it's this arrow, actually. Hold on. Do I need a negator here? I actually don't think so, because of this arrow, right? If I fold A and B together, this arrow goes down, up here, to here, and then back to itself. But the arrow goes into its own circle. So what that means is it counts itself, so everything else has to sum to 0. But I think this could not be a negator. I think I could have 1, 3, 1, 2, 1, right? 1, 3, 2, 1, and that seems to work. And this could be literally any digit. So I don't see a problem there. Well, that's not 6 or 8. So I get a 4, 9 pair here. Ah, there we go. I get a 4, 9 pair here, which means that's not a 9 anymore, which means this is 4, 9. The 6, 8 pair puts a 4 here. It seemed like it was going to be useful for a minute. Actually, where's my what is in here? Now 9 is not in here. Okay. That's it. So the biggest the negator could be actually here is a 5. In fact, there is a 5 somewhere in here, so that seems likely. So now I can probably do some more limiting on this, right? Because this is at most, the lowest it could be is -4. That's 4, 5, 3. So this can be 7 because I make this 10. So that can't be 7 anymore. So it's 6 or less, but 2, 4, and 5 are taken. Oh, but this can't be 9 either. So this can't be 6 because if this were a 6, this would have to be 9, I think, right? 6, 7, 15, 13, minus 4 is 9, which it can't be. So this isn't 6. I got a 1, 3 pair now. But now I think I just have a ton of freedom here. Well, hold on. What's the positive digit here? Because actually 4 is in here too. If this is a 1, my positive digit in here has to be at least 3. Meaning this could be 3 and -5. It's only -2. So in fact, yeah. Hold on, how does this work? The smallest, between these 3, because there's no 2 anywhere. The 2 is in one of those spots in the box. The smallest I can make the 2 positive numbers here are 1 and 3. And I make the negative of 5. That's -1 on net from this box. -1 on net from this box cancels with this. Oh, but that was 6, and that's exactly what I could do. Okay. Oh, hold on. Now this has to be 2, though, because this is at least 6. This is at most 9. This can't be more than 3. So this is my 2. Okay, this has to be a _𝐿-𝐾 cage, at least here, because I can't make one negative number. Like the smallest I can make it is 1 to 8 is 36 minus 9 is 27. So I can't have 14. So there's a 1, 4 in this cage. And presumably that's also going to be true here. But let's go back a second. This can't be 6 anymore because that'd be 4. 8 goes with 6, 9 goes with 7. So that's not an 8. And this is 6, 8, 9 as well. So this is a 6, 7, 8, 9. Yeah, this is 4 or 5 with a 1 or 3. Okay. Actually, now I wonder if this has to be the negator cell. Or sorry, if it can't be the negator cell. Because if this is the negator cell, the most I can make this is 2, 2, 3. Which is 7, 0. But then I have a negator cell will make it negative and not 0. So these have to sum to 0 because this arrow takes itself. So these sum to 0. The most I can make this is 7. And so if this is negative, the sum will definitely be negative. So this has to be positive. This has to be negative. I don't think I can make this a 1. Oh, no. And now these are 0, right? So, I mean, these 4 digits sum to 7 because these 5 digits sum to 0. So those 4 digits sum to 7, which has to be 1, 1, 3. 1, 3, 2. Yeah, this one cleared this. This is a killer cage, which I think means there's an 8 in here. Hold on, this cell looks down. So those aren't. So I have a red 8 in here because 1 to 9 is 45. Take out the 8, that's 37. Take out the 8 again, that's 29. This is a 4 or 5 pair. And I bet these will just align, right? Because, let's see. Oh, no, that's a 3. There we go. Okay, but that's all I get. So 3, 4, 12, 10, 11. Yeah, minus 4 is 7, minus 5 is 6. So these sum to 11. That's all I get. Yeah. All right. Still, I mean, we did a lot there. So this is the 4 or the 5. Okay, hold on. Where are my? Okay, I think I can think about 2 of these red cells at a time, and figure out that this is 4. This is 5 actually. Because what happens if this is 4? If this is 4, oh, and I have 1 here, right? Yeah, okay. If this is 4, I get 8 here. These need a 5 and a 9. Well, where are they going to go? Because 5 and 9 look at this top row. So this column, easier. What is the red cell in this row? All I have left is 4, 5, and 9, and 5 and 9 are gone. So one of these is a red 4. So that actually does that and tells me there's a red 4 somewhere here. But more importantly, that means this is 5. I'm just going to do this. I have a red 9 here, which makes me want to put a 9 here, but I don't know that for sure. This tells me this, right? So this is 6. Let me just do the math again. 1, negative 4, 4, 8, 6. Yeah, that's 6. 6 plus 2 is 8. 8 does that. 6, 8, that's 9. That's 7. That's 4. Okay. Oh, this is now a 4, 9 pair. 5, 6, 7. So this is 5, 6. So we get 7 here. It's just normal Sudoku. That's not a 1. This is only 1 or 2. This is 3 or 8. Oh, but it's not 8 because I need an 8 down here. So that's a 3. That's a 1 and 2. So I get an 8 here, actually. 1, 2, 4, 9. This is 6 or 7 only. Okay. I need a 1 in here. Trying desperately to not determine whether or not this can sum to 29. 1, 2, 4, 6, 7, 9. Yeah, that's not helpful. I probably have something I'm not seeing, but I don't see any more obvious Sudoku to do here. What do I need for here? Sure, here 2 and 3. All right, so let's think about this. I don't think I can do 29 here, which I think is going to tell me that I can't put a 9, because if this is a look and say cage, 1 9 is here and the other 9 will be here. But like, what is the minimum of this? It is, let's say this is 1, 2, 3, 4, 5, 9. 2, 3, 4, 5 is 14, 13, 22. Minus 8 is 16. Plus 15 is 31. So 15 is the minimum I could make these 5 squares. I don't even think I could really do that. But I think, let me just do that again, because it worries me. So if this is 1, 2, 3, 4, 5, but with a minus 1, that would be 13. Plus 9 is 22. Minus 8 is 14. Oh, it's 14. I did do that wrong. 29. It does work. Wow. Shoot. One more time. Sorry. 1, 2, 3, 4, 5, 13, 22. Minus 8 is 14. Plus 15 is 29. Yeah, I don't know what I did the first time. You can just barely do it. Which makes me think that's actually how it will be. But let me just keep plugging at this. 1, 3, 6, 9. This is 3 or 6 only. This is 1 or 3. 1, 6, 9, 3, 6, 9. This is not blue, because the blue in this row is 4, which this can't be. Oh, same here. The blue in this row is 4, which this can't be. So that's blue. So this is red, and the red in this row is 9. And the red in this row is 4. That's 8. Yeah, another troll emoji. These are now red. I'm just going to get rid of the blue. That does not look great. I'm gonna make us. I mean, I don't even really need these. Well, I might need them for the sums, but I'm just gonna make these like a nice light gray color. 1, 2, 4, 9, 5, 7. Yeah, there's a 5 or a 6 here. Okay. Now this doesn't work because I can only have 1, 1 or 2 here. I might have had that before and didn't notice, but this 2 9s thing, this is a 2 9, because if this were 29, or the minimum I can make this is 1, 3, 4, 5, 6, which is 4, 5, 6 is 15, 1, 3 is 19. Minus 8 is 11. 2, 3, 4, 5 is 14. Minus 1 is 13. Plus 9 is 22. 22 and 11 was 33. Yeah, it doesn't work. So I need, this is actually a 2 9s cage. One's here, one's in here, so it's got to be here. 9, 4. That doesn't actually do anything. Oh, this 4 just looked up, so much simpler. Much simpler. There's got to be some Sudoku then, because all the cages are done, the arrows, everything's done except Sudoku, I think. So let's just do Sudoku. Let's try and actually do Sudoku. What do I need in here? 8. So 8, 5. Yeah, there we go. 7, 6, 5, 6. This is a 3. This is a 2, 5 pair. 4 here that I have marked presumably correctly. We'll see. This is a 1, 6 pair, which I know the order of. 1, 1, 1 in one of those. 5, 7, 9. 5 here, 7 here. 1, 9. 2, 3, and 8. 8 goes here. 2, 3 pair here, which I don't know the order of yet, but it does resolve that. These are 2, 3, 6, 7. 3 goes in here. I don't know where. 6 goes in here as well. 3, 6. Oh, sorry, 1 looks up here. 2, 7. I do know the order of. 2, 7 resolves the 2, 3. Resolves the 3, 6. Wow. Why then 'tis none to you, for there is nothing either good or bad, but thinking makes it so. To me, it is a prison. From Hamlet. Very nice puzzle. I really like that. I really like that. Yeah, so thank you for sending that in, and thank you for watching. And yeah, see you next time. Bye.